Hello students, welcome to this module number 3. Here we are going to discuss about chapter heat treatment. In that some of the concept that is what is meant by recovery, recrystallization and grain growth, and after that we understood what is meant by a normalizing process. Okay, so first of all, what is recovery? So before that we have suppose example, suppose a plastic deformation of taking place any in a cold working process, like a cold rolling, maybe cold forging or bending, etc. It causes change the grain size and grain structure of hardening the material, strain hardening. So and also it increases the dislocation densities. So to defects this generated can store about 1 to 10% of the strain energy supplied to the plastic deformation. So this restoration to the initial state of the material can be achieved through the some annealing process. So in three different stages of transformation, like the recovery, recrystallization and grain growth. These are all comes under the annealing because of that annealing process to be done. So these are the three different stages of transformation. So let us discuss one by one what is meant by recovery. So what happened during recovery, sometimes the stored internal strain energy is going to be relieved at high through the dislocation motion due to the enhanced atomic diffusion at higher temperatures. So recovery process does not involve any changes in the grain structure of cold worked metals. So instead of led to the reduction in the number of dislocation or dislocation of arrangement, it takes place within the existing grains. Okay, a small changes in hardness that are going to be sometimes observed during this recovery can be attributed to the decrease in dislocation and point defects, and density and other things are growth to the sub grains. So this is about the recovery stage. And when we come to the recrystallization, what happened after recovery is complete? So the grain are going to be still in a relatively high strain energy rate state. So due to this increasing of temperature, there is a formation of a few new set of strain free or strain free and unaxial grains that have to low dislocation densities. So this process of formation of new set of grains is what we call as recrystallization. Suppose example, and even though for the temperature at which these grains are going to be formed, we call it as recrystallization temperature, and the driving force to produce this new grain structure to internal energy difference between the strained and unstrained material, there is also some force is going to be happen, and the strain energy, strength and hardness of this stage, it is decreases considerably, and ductility is also increases. So this is about the second stage of recrystallization, and finally it reaches grain growth. So further it is going to be annealing, and at the same temperature or slightly at a higher temperature, what happen, the strain free grain continues to grow. So as these grains are growing, increases in size, the total grain boundary area decreases, and resulting that a decrease in the total energy. So this strength and hardness of the material is decreases, resulting that in increasing the ductility of the material. So this is how the different stages it is crossed the transformation for the annealing process. So next one is normalizing, or we call it as air quenching. Simply we call it as air quenching. So what is meant by annealing process? Like it is similar like a full annealing process, so but it has a faster rate of cooling than other that is the full annealing, that is either in still air or by the blast of air. So this is the method. So why we have to do this normalizing? Because to refine the grain structure, okay, to produce a more uniform and desirable grain size distributions that results in harder or stronger the steels, and to produces more uniform it is of the structure it is going to be used, and also it is improved machinability and also it is obtained relatively a good ductility without the hardening of the material. So this is about the purpose of doing the normalizing. The process is going to be taken place from the normalizing. See this figure, how the normalizing temperature is varying. So it is exactly along the y-axis temperature in degrees centigrade, and along the y-axis percentage of carbon along with the normalizing temperature, percentage of carbon will be there. So the metal is going to be heated about above 30, 20, 50 degrees centigrade. So the upper critical temperature, that is A3, what we call A3 and ACM line, is going to be held there for certain duration. Later it is allowed to cool and surrounding air to the room temperature. You can see here from this graph from A3 and AM3 ACM line, as at a certain duration it is held at their place only, and later further it is allowed to cool for the surrounding air to the room temperature. So as faster the rate of cooling results in a ferrite and perlite structure for eutectide steels, even for the perlite microstructure for the hyper eutectide steels, and perlite and cementite structure for the hyper eutectide steels, and only for the perlite structure for eutectide steels are going to be we can upload here. So that the hardness and strength of this material is slightly greater than that of which would have occurred in with full of annealing. That is what it is, almost similar kind of full annealing, and but and also to having faster rate of cooling. So, and where we are going to use this kind of normalizing, usually that is performed on a roller kind of process and the cast steels, on components of subject to high stresses and on high carbon steels. We are using this kind of applications. So this is about the normalizing method. So you may ask, what are the difference, major difference between normalizing and annealing, you may ask. Okay, so what happened in a normalizing, it can be applied above the upper critical temperature for both hypoeutectide as well as hypereutectide steels. Whereas annealing, what happened, it is applied above the upper critical temperature for hypoeutectide steels, and also it is slightly above the or below the lower critical temperature for the hypereutectide steels. And as compared to here, annealing, the normalizing is the fasting the cooling rate, but as per the concern about the annealing, the cooling rate will be slow, that is relatively slow. And one more difference is as greater the hardness and strength is going to be obtained from the normalizing, but in case of annealing it is also relatively low. And the finer the grain size, okay, as much as it is very fine by doing this normalizing, as we are doing normalizing process, the grain size will be very fine, but here from the annealing process it is less, and the normalized parts are soft and easily machinable, but here it is very difficult, it is very difficult to machinable from the annealing. So these are all about difference. One more difference we can say is as the carbon content of this material it increases, and ductility of the normalized high carbon steel drop about 1 to 2% of level. Okay, but whereas if you take for the annealing, as the carbon content increases and the annealing maintains the percentage of elongation by around 20%. So we can compare the percentage of changing this process and how much it is. So this is about the normalizing and annealing process. So whenever they may ask for the examination difference, so you must be able to explain very clearly around 5 to 6 points we can explain by defining that is normalizing and that is the annealing process. So this is all about normalizing and annealing difference. So this annealing, this normalizing also we call it as what we call air quenching. Air quenching, that you remember in the examination, instead of asking normalizing, they may ask for the air quenching also. Explain about the air quenching. So at that time you should answer for the normalizing method what we have discussed right now. Only the thing is you observe that it is going to be heated about the upper the critical temperature, that is 50 degrees centigrade above this critical temperature, like A3 line and AM line we can observe in the figure, that it should mention in the explanation. Okay, I hope you understood for this concept. Will further topics will be discussed in the next video.